Question 3. Anne wants to know if males and females prefer different brands of frozen pizzas. She bakes 4 dozen pizzas made by each of 4 manufacturers, which she labels brands A, B, C, and D. She then selects a simple random sample of 48 students, records their gender, gives them 1 slice of each brand, and asks which brand they like best. Here are her results. Okay. The appropriate null hypothesis for Anne's question in this problem is like. All right, so we need to first figure out which of the 3 chi-square procedures is appropriate for this type of data. One thing I picked up on is that it says random sample, so it's not plural. She took 1 sample, and then the data are in a 2-way table. All right, so this is going to be a chi-square test for independence. And the way we write the hypotheses for this test, I'll be very general here, is we write no association or yes association. Okay, forgive me for not including the context here. I just want to get to the main idea is that yes or no, there's association. All right, so the correct null hypothesis, right, is going to be something of the flavor no association. Okay. So we're going to eliminate A. That's actually sounds like the alternative hypothesis. B, okay, I don't want to eliminate that one yet. Okay, C, sorry, no. D, the observed count, no. E, male and female have the same distribution. No, okay, so to say that 2 things are independent is equivalent to saying there's no association between them. Right? So this hypothesis is equivalent to independence, and this one is equivalent to dependence. All right, so we're going to go with choice B. Question 4 piggybacks off of the previous question. So are the conditions for a chi-square test of association / independence, see there you see, right, that either of the 2 terms or languages could be used, are the conditions met? All right, so let's just look here. Okay. Random condition is met since she took a random sample. 10% condition is probably met. Yeah, 48 students is probably less than 10% of all possible students she could have did the study with. All right, the one I'm not super sure about is the large counts. So these are the observed counts, okay, but are the expected values at least 5? So the fastest way to figure out the expected values is to use the matrix menu on our calculator. We're going to define a 2x4 matrix. Okay, for the expected counts, we've got 2, we've got 4, 6, 7, and then 11, 5, 6, and 7. Okay. Next, we're going to go ahead and run the chi-square test. Okay. The test will auto-save the expected counts in matrix B. I don't know if you saw there, right, that it says observed counts matrix B. Okay, so we don't have to figure it out ourselves. The calculator figures it out for us. So now I'm just going to go back to the matrix menu, select matrix B, and then just make sure each value here is at least 5. Okay, and right there, kind of, sort of, it's kind of being covered up. Okay, scroll this way. All right, well, there's one for sure that's not at least 5. Okay, 3.5. All right, so we have a violation of the conditions, at least the large counts condition. Yeah, so let's look at the answer choices. So we can eliminate the ones that say yes. All right, C, no, because the distribution for each gender is different. Okay, that's not one of the conditions. No, because not all observed counts are greater than 5. Okay, well, that's wrong because it's referring to the observed counts. No, because 25% of expected counts are less than 5. Okay, so that's the violation. Okay, I don't know if it was 25% of them or not that would be 25% of 8 would be 2, right? So I see there's 1 there. And I don't understand how this thing is scrolling, but let's try this instead. Let's go to Edit and then choose Matrix B. All right. So we've got 1, we've got 2. All right, so it looks like there are 2 out of the 8 expected counts are less than 5. That would be 25%.